Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have 1 divided by x minus 1 into x plus 2 the whole square, right? So what we've been given is dy by dx and we've been asked to find y, right? So my y is nothing but integral of the given expression. So there we are. That's our y. I know that I do not have y in a simple format whose antiderivative I know by first principles. So I will have to resolve the given expression into a much simpler format, right? And how do I do that? Looks like I have a rational expression in place. So I'm going to be resolving them into partial fractions, right? So how do we express this? For a minute, I'm going to keep y aside. I'm going to pick up the expression given to us and try and re-express it using partial fractions, right? And I request you to take a look at my description where I would have explained how to handle different types of rational expressions. How do we represent them in the partial fractions? So let's express this using partial fractions. So I can express this as a divided by x minus 1 plus b divided by x plus 2 plus c divided by x plus 2 the whole square. So now step 2, what I do is cross multiplication, right? And then I re-express the expression as follows. My first part, which is a divided by x minus 1, when I cross multiply, I get a into x plus 2 the whole square. Now I come to the second part, which is a b divided by x plus 2. When I cross multiply, I get b times x minus 1 into x plus 2, right? And finally, I come to the third part, which is c divided by x plus 2, the whole square, which is nothing but post cross multiplication, I get a c into x minus 1, right? Now my denominator remains as it is. Let's expand this particular expression and let's see what do we get. So my first one, which is 8 times x plus 2 the whole square, which is nothing but x square plus 4 plus 4x, right? And then I come to the second part, which is b times x minus 1 into x plus 2, right? X square. Then I have a plus 2x and a minus x, which means I get a plus x and I get a minus 2, right? And then I have a c times x minus 1, right? So that's the expression we have, and for now our denominator remains as it is. So let's combine the x squared terms to start with. I see that I have an a plus b, which is my coefficient of x squared. So let's write that down. So I have a plus b times x squared. And then for my x, I have 4a plus b plus c, right? So that's my coefficient for x. And then finally, I come to the constant, which is nothing but 4a minus 2b minus c, right? And then I retain the denominator as it is, right? So let's come down. Now the expression given to me is nothing but 1 divided by x minus 1 into x plus 2 the whole square, right? And if I try and equate it to this particular expression, what I have arrived at, right, then I see that this term does have coefficients of x squared and x. But then the term given to us has only a single constant, which is 1, right? So how do I find out what are my a, b, and c terms? So my coefficient of x squared in the given expression is 0, right? Because I just have a 1 in the numerator. Similarly, my coefficient of x in the numerator is also a 0, which means I have 4a plus b plus c also equal to 0. right? And then finally, I have 4a minus 2b minus c equal to 1 because the constant term that we have in the numerator is a 1, right? So now we can go about solving for a, b, and c, right? So what do I get post solving? So my a will be equal to 1 by 9. My b will be equal to minus 1 by 9. And my c will be equal to minus 1 by 3, right? And folks, if you've not understood how do I go solving for a, b, and c, please do mention in the description. I'm happy to help you out there. Some of you might find it pretty simple, but I know that some of you, in case you have problems solving for a, b, and c, so do mention in the comments, right? So this is a, b, and c, right? Now I go back to the expression, what I originally wrote, right? I'm referring to this expression. Let me highlight this in a particular color, say green. So I have a divided by x minus 1 plus b divided by x plus 2 plus c divided by x plus 2 the whole square, right? So I'm going to rewrite my expression post resolving them into partial fractions, right? And what's the expression I have? I have a divided by x minus 1, and in place of a, I have 1 by 9, right? So I write my 1 by 9 as it is, right? And then I have 1 by 9 times 1 by x minus 1, right? So let's write that down. Plus b times 1 by x plus 2, right? So my b is nothing but minus 1 by 9. And then finally, I have my c, which is minus 1 by 3 times 1 by x plus 2 the whole square, right? So let's write that down. So this is the expression post simplification, right? So now my y is nothing but integral of this expression, right? So there we are. And I can apply the sum rule of integration to rewrite my y as integral of each of these expressions, right? So this is what I have. My y equals 1 by 9 times integral of dx by x minus 1 minus 1 by 9 times integral of dx by x plus 2 minus 1 by 3 times integral of dx by x plus 2 the whole square, right? Now from here on, I think this is not very difficult for us. So for the first two expressions, right, we have a function of the type 1 by x, right? So which are those two rules I can use to solve expressions 1 and 2, which is dx by x minus 1 and dx by x plus 2, right? So I'm going to write them down. So there we are. Assuming I know integral of f of x dx equal to g of x plus c, then my integral of f of ax plus b times dx is equal to 1 by 8 times g of ax plus b, right? And integral of dx by x equal to ln of mod of x plus c, right? So for the first and the second expressions, we're going to be applying these two rules to solve the particular, integrals, right? So let's do that first before we jump to expression 3. So there we are. I have written down, my f of x, g of x, and f of ax plus b for both expression 1 and 2. So let's pick up expression 1. I'm going to highlight it in green, and I'll highlight it in green in my y as well. So we are on the green expression right now. So my f of x equals 1 by x, my g of x equals ln of mod of x. Therefore, my f of x minus 1 equal to 1 by x minus 1, my g of x minus 1 equal to ln of mod of x minus 1 plus c, right? So I go to my y, my first integral. So I have my constant 1/9, which I write it as it is, right? And then express my answer for the first integral, I actually use this particular expression, right? Integral of f of x dx equal to 1/8 times g of ax plus b, right? Integral of f of ax plus b dx equal to 1/8 times g of ax plus b plus c, right? So I've worked out my g of ax plus b for the first expression, and I need to plug in my 1 by a. I don't have to worry about my a because it is a 1. So I can directly write it as ln of mod of x minus 1, right? And now we come to the second expression, and let me highlight it using a different color. Integral of dx by x plus 2. Let me use a yellow color. And then I'm going to be using what I worked out in the expression 2 here. My f of x is the same, which is 1 by x. My g of x is ln of mod x plus c. And my f of ax plus b is f of x plus 2, which is 1 by x plus 2. And my g of ax plus b, which is g of x plus 2, is ln of mod x plus 2, right? And now I go and use again and let me use a different color here. Maybe I shouldn't have highlighted this in green. I should use turquoise. I go ahead and use what I have highlighted here in turquoise, my integral of f of ax plus b dx, which is nothing but integral of f of x plus 2 dx, is equal to 1/8 times g of ax plus b plus c, which is 1/8 times g of x plus 2 plus c, right? So my a is 1, so I don't have to worry about it. But remember, I have a minus 1/9, so I will have to plug in that. So I have minus 1/9 times ln of mod of x plus 2, right? So that's the answer for expression 1 and 2. Now I come to the third expression, right? My third expression is of slightly different type. I have integral of dx by x plus 2 the whole square. And which is that integral I will have to use to solve this particular problem? I will have to use integral of x to the power n dx. Integral of x to the power n dx equal to x to the power n plus 1 divided by n plus 1 plus c, right? And in place of x, I have x plus 2, and in place of n, I have minus 2, right? So let's write down our expression 3 here. So my expression 3, which is integral of dx by x plus 2 the whole square. So I'm going to be using integral of x to the power n dx equal to x to the power n plus 1 divided by n plus 1 plus c to solve the expression 3, right? So when my f of x equal to x to the power minus 2, which is nothing but 1 by x square, my g of x, I apply the integral formula to arrive at minus 1 by x, which is actually minus 1 into x to the power minus 1. And you apply this particular formula, x to the power n dx, and you will arrive at that, right? Let me highlight that in turquoise as well. And now all I do to arrive at f of x plus 2 is to replace my x by x plus 2 in the f of x expression. I get a 1 by x plus 2 the whole square. And that's the expression for which we are trying to work out our antiderivative. And then correspondingly, my g of x plus 2 is minus 1 divided by x plus 2, right? Where I just replace my x by x plus 2 in the g of x expression, right? So now I go back to my third expression, which is minus 1 by 3 times integral of dx by x plus 2 the whole square. Let me use another color. Maybe I'll use, say, orange. And then I'm going to use what I have arrived at from expression 3 out here. And I'm going to connect these two. I have minus 1 by 3 times, right? Now, I again go back, I use the first rule what we have written, integral of f of x dx equals g of x plus c, then my integral of f of ax plus b dx equal to 1 by 8 times g of ax plus b plus c, right? So in this case, again, like what our expression 1 and 2 were, we have a equals 1, right? So I don't have to worry about my a. My g of ax plus b is nothing but g of x plus 2, which is a minus 1 divided by x plus 2. So I have a minus 1 by 3 already there, right? Which becomes a plus 1 by 3 times 1 by x plus 2. Remember, folks, I have a constant in each of these expressions. So I'm going to combine all the three constants and write them as one single constant, right? So there we are. That's the answer for the particular problem. Let's take a look at it if we can do any further simplification. The answer is no, which means we will highlight our final answer in pink. So I hope you found my content useful. Please do subscribe to my channel and support. Thank you.